Welcome guys to combinations and permutations. Okay, probability. This is what it's all about. Okay, we're looking at probability in the general course. I'll be honest with you and say that I believe this is one of the most challenging parts of probability. You might disagree, but I think this is tough. Okay, to start off with looking at combinations, permutations, we're going to look at, I guess, a brief sort of idea of what a combination is. Okay, so what we're going to say, we got a little classroom. Okay, I'm going to draw my classroom here. Okay, it's my little classroom. Inside here, this is the classroom door. Outside the door, I've got 5 people standing outside. And what I'm going to do, I'm going to ask these people to, or I'm going to want to find out how many possible ways it is for these 5 people to line up in one straight line. Okay, so for example, you know, this might be Bill, this might be Ted, Sally, John, and Pip. Okay, so I want to find out how many possible ways they can line up. So for example, you know, we've got 5 places here for them to stand. So if I say this is the first place here, so the first person comes in the room. Now, how many possible people can come in and stand in that position? Well, there are 5 people outside my room, so 5 people can stand there. So let's say, for example, that first person's come in and stood there. My second position, how many people can now stand in that position? Well, there are 4 people outside, so 4 people can stand in that second spot. Okay, that person's there. Then 3 people. Then 2 people. Then 1 person. So if I try to work that out, it's 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20, times 3 is 60, times 2 is 120, times 120. So there are 120 different possible ways for those 5 people to stand in a straight line. Now that 5, 4, 3, 2, 1 is a special pattern, I guess. Likewise, you might have 3 people coming in and wanting standing in. How many ways can 3 people stand? Well, I've got 3 times 2 times 1. Or if I've got 6 people, 6 times 5 times 4 times 3 times 2 times 1. Now these are special number patterns. Okay, and you may have heard this before, but this is called a factorial. For example, this one here can be called 6 factorial. Now that little exclamation mark means factorial. And what it means, if I've got 6 factorial, it means I start with 6 and I times it by the next lowest number all the way down to 1. So 6, 5, 4, 3, 2, 1, like you got there. Or if I've got this one here, 3 to 1, that's called 3 factorial. So what might this first one be called? Hopefully you may have said 5 factorial. It's just a quick way of writing 5 times 4 times 3 times 2 times 1. And if you go into your probability mode in your calculator, okay, so just to refresh how to do that, we go into our run mode, we go to options, F6 until we see probability, and you can see you got a little factorial there. So if I use that 5 and that factorial, okay, and then press my enter key, you got 120, and that's what we had there originally. So basically it's just a short way to write those numbers, 5, 4, 3, 2, 1. Okay, so that's basically what a combination sort of looks at. You can see we've got a lot of different combinations there. Okay, popular ones are things like, how many ways can you have, you know, if I've got 3 entrees, 2 mains and 4 desserts, how many different combinations can I have? That's a very popular thing to have. Okay, so things like this as well, you know, how many ways can I seat 4 people in a line? Just like that, 4 factorial. Okay, so let's have a look at an activity I like to start with. Let's say we've got a group of 5 people. Okay, let's say we've got our Bill, we've got Ted, we've got John, we've got Sally, and we've got Pip. 5 people in. What we want to do to start with, we want to arrange these 5 people into a group of 2. Just want to choose 2 people out of that group of 5. How many possible ways can I create a group of 2? Okay, maybe you want to pause and have a think about this and come up with an answer. Go. Okay, sometimes, or most people like to use like what we call a box method. We're choosing 2 people, like we did with the last 5 people. Now, in that first position, how many different people can I have? Well, we've got Bill, Ted, John, Sally, Pip. That's 5 different people. Now that I've chosen that first person, there is now 4 people left. So 5 times 4 equals 20. So in theory, we should have 20 different combinations. Let's have a look if that works out. Okay, so let's say we've got Bill and Ted. We've got Bill and John. We've got Bill and Sally. We've got Bill and Pip. Okay, let's say we start with Ted. We've got Ted and Bill. We've got Ted and John. We've got Ted and Sally. We've got Ted and Pip. However, what you might realize is that, hold on, we've got Bill and Ted and Bill. Are they not the same group? They're exactly the same group. They simply asked for group 2 and they're both the same group. So actually we don't want to have that one there because we've counted Bill and Ted one too many times, I guess. Okay. Next one. Oops. John and Bill. John and Ted. John and Sally. John and Pip. Now likewise, you'll notice that we've already counted John and Bill because that was Bill and John. John and Ted because that was Ted and John. So we can cross those out. Now again, we go start with Sally. We've got Sally and Bill. We've got Sally and Ted. Sally and John. Sally and Pip. I'm going to cross out Sally and Bill because that's the same as Bill and Sally. Sally and Ted. Ted and Sally. Sally and John. John and Sally. Okay, and the very last one we've got is Pip. We've got Pip and Bill, which we know is the same. Pip and Ted, which is the same as Ted and Pip. Pip and John, which is the same as John and Pip. We've got Pip and Sally, which is the same as Sally and Pip. So all those ones are all the same also. Okay, so in fact, how many combinations have I actually got? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've actually got 10 different possible combinations. Now we said 20 to start with. And what we needed to do, we didn't realize that when we counted these 20 combinations, we counted Bill and Ted and Bill to be 2 different combinations, which actually they're the same. So in that case, what we say, order does not matter. The order doesn't matter. Okay, and actually the way we get 10 is by doing divided by 2 factorial. There are 2 boxes, so 2 factorial is the way we can do it. Because 2 factorial is 2 times 1, which is 2. 20 divided by 2 is 10. Now, there is a way we can do that on a calculator, because what that's called, that is actually called a combination. If we included every single possible combination, that would be called what we call a permutation. That's when order does matter. We'll look at that in the next example. But this is called a combination. You'll find on your calculator next to that x factorial that you saw before, there is one that says NCR. And if you actually type in your calculator, remember we had 5 people to choose from, and we want to create a group of 2. If you type that into your calculator, you'll actually come up with the answer of 10, because we're looking for a combination. Now, it's going to make more sense when I look at the next question. which starts with, says, how many ways could I choose a class captain and a vice captain? Well, if I've got Bill and Ted, and I've got Ted and Bill, are they different? Well, in the first one, Bill here is the class captain, and Ted is the vice captain. But in the second combination, Ted is the captain and Bill is the vice captain. So these two things are different. And in other words, order matters. It matters who comes first and who comes second. They are two different combinations. Now, because order matters, this is what we call a permutation. And I'll say there are always more permutations than combinations. Okay? Because obviously, if order matters, then these are two completely different combinations as opposed to in the first question when it only counted as one. Now, on your calculator, you'll see the NPR button. Now, likewise we did here, we did 5 NCR2. We can do 5 NPR2, which means we've got 5 people to choose from. It's a permutation, and we're looking at how to make two different sort of things. A vice captain and a captain, so two things. So if I put that in my calculator, that actually just means 5 times 4, which is going to give my answer of that 20 combinations, which was similar to that first question. Look, it is difficult to start with, but I really advise you to keep on going this way and having a crack at it. We're going to do another question like that. Okay, let's say I've got the digits 3, 5, 6, and 7, and we want to make a 3-digit number. Okay, 3-digit number. How many ways can we do this? Well, we need to figure out, is this a combination or permutation question? In that case, let's take an example. I always like taking an example. Let's take number 356. 3-digit number. And let's take the number, let's rearrange them, 6, 5, 3. Are they different combinations? Are they different numbers, or do they mean exactly the same thing? Well, hopefully you've realized because these are numbers, that makes 356, that makes 653, therefore the order matters. The order does matter. Last question didn't matter because we made a group of like 2 or 3 people, which they're in the same group. Didn't matter where I put that person, it was the same group. But in this case, order matters. So this is a permutation. So a permutation. So if I now say I've got 4 people to choose from, it's an NPR questions permutation. We're making a group of 3. Put that into my calculator, we get the answer of 12. Oops, no, sorry, 24. Okay, which means 4 times 3 times 2 times 1. Okay, 24. Nice and easy. Okay, the very last question is neither a combination question or permutation, so an NCR or an NPR question. It's a little bit different. We've got a card number plate contains 2 numbers, 2 letters, and then 2 numbers. So 13 NP 27. It's an example. How many different plates are there? So what we're going to do, we're going to use the box method. 2 numbers, 2 letters, 2 numbers. Okay, so how many different numbers can go in this first box? Well, we've got numbers from 0 to 9, so that's 10 numbers. 0 to 9, 10 numbers. We've got 26 different letters. 26 different letters. We've got 10 different numbers, 10 different numbers. And all I now need to do is get my trustworthy calculator out and then times them all together. So we're doing 10 times 10 times 26 times 26 times 10 times 10, because there are 10 digits between 0 to 9 and there are 26 letters in the alphabet. Okay, and then we type that into the calculator, find the answer, which is going to equal 6 8,760,000 different combinations. Okay, now the last question there says, what's the probability that I choose a plate beginning with N? Well, in the two letters, I mean, in the two letters there. So we've got a plate there, like this. So for the numbers, how many numbers can I put there? Well, we've got 10 numbers. We've got 10 numbers, but we want it beginning with an N. So we want an N here. So how many N's are there in the alphabet? There's only one N there. There's 26 other numbers. There are 10 digits and 10 digits. So I've got 10 times 10 times 1. That's the hard one because that's got to be an N. Times 26 times 10 times 10. So 10 times 10 times 1. Again, because there's only one N, it needs to start with an N. Times 26 times 10 times 10. Put that in my calculator, we get the answer of 260,000. Now remember, that's how many combinations there are that start here with an N. If I want to put that as a probability, we put it over all the possible combinations, which is 760,000. Okay, and then we let our calculator do the work. And then funny enough, it actually comes out with the answer 1 in 26. So that's a probability that I'm actually going to get a license plate that starts with an N. Okay, lots of food for thought here, guys. It is tough. Please just get your HSC questions and keep on repeating and repeating and repeating. It's a good idea to get questions where it can, in your textbook, if it's both an ordered and an unordered selection, so you have to try to choose between the two of them. But again, the best thing to do is to grab your HSC questions and just go and practice, 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 practice. Any problems, guys? Let me know. Hope this has been useful. Make sure you're revising. Enjoy.